You rotated the phone, your search query disappeared. That's not a bug. It's a fundamental architectural reality you haven't mapped out yet. Your query lived in the activity died. This explainer is your complete mental model for Android Lifecycle and Architecture. Over the course of this curriculum, we're going to build your intuition so you never have to memorize another API. Watch these in order. Each builds directly on the last. Okay, let's dive into this core tension. When you rotated the device, the activity was destroyed. The real question isn't just, how do I fix the bug, but rather, who should have owned that data in the first place? To answer that, we have to establish a true mental model of the system, starting at the absolute root. Section 1. The Platform Layer. OS-level foundations. Here's what nobody tells you on day one. We need to define the foundational boundaries of Android before we put anything on a screen. Your app doesn't start with a screen. It starts with a process. This is the OS-level sandbox. It's the definitive boundary that holds absolutely everything else in your application. Inside that process boundary, the very first object created is the application. Think of it as your initialization hub. It fires off the setup spokes for things like logging and crash analytics before any UI is ever drawn. Now we get to the activity. This is your screen owner card. One activity card equals one screen, and its entire existence is dictated by the Android lifecycle. It's born, it lives, and it dies based entirely on what the user is doing. And this brilliantly illustrates our opening problem, a configuration change, like a screen rotation. Look at the timeline. The activity goes from created to started to resumed. But when you rotate, the activity card is completely destroyed and recreated from scratch. But notice, the process boundary holds firm. The sandbox didn't die, only the screen did. So if the screen dies, where do we put the data so it survives? Section 2. The ViewModel world. Surviving rotation. The ViewModel is the specific component designed to survive this exact rotation drama. It's a persistent state container that owns what's on the screen. While the activity card dissolves and rebuilds during rotation, this container stays alive, holding your search query safely. But here's a crucial detail that's often missed. The ViewModel doesn't just magically float in the void. It survives exclusively because the ViewModelStore holds it. The store persists across the recreation and seamlessly hands the exact same ViewModel back to the new activity card when it spins up. Now, you must draw a strict distinction between a simple screen rotation and a true process death, where the OS wipes your entire sandbox to reclaim memory. The ViewModelStore does not survive process death. To recover from that, you need the SavedStateHandle. It acts as a pinned key value chip, holding just the minimum information required, like a product ID, to rebuild the app. So, the crucial point is this architectural rule. Owner determines lifetime. Whether your scope is bound to a fragment, an activity, or a nav graph, the owner strictly dictates how long that data lives. When the owner truly finishes, the data clears. Section 3. The repository layer. Single source of truth. There's a very common misconception here. The wrong model treats the repository as just a pass-through API wrapper. The correct model recognizes the repository for what it actually is, the strict, authoritative owner of your application data. It alone decides whether to pull from the network, a local database, or memory cache. This brings us to the single source of truth. Inside the repository, you have one authoritative source, a state flow. When that data changes, every single ViewModel observing it gets the update simultaneously. It's the mechanism that makes your entire data layer coherent. One source, many readers. Section 4. State types. UI versus business state. You have two distinct types of state. UI state is an ephemeral snapshot, things like loading spinners and error messages, strictly bound to one specific screen. Business state is persistent data, like a shopping cart, held at the app scope in the repository. The ViewModel's entire job is to take that persistent business state and transform it into an ephemeral UI state snapshot for the activity to render. Section 5. Unidirectional Data Flow. The Android Pulse. This is the exact pulse of a healthy Android app. Step 1. An event, like a button click, travels up from the UI to the ViewModel to the repository. Step 2. The repository does the work and updates the state flow. Step 3, the new state flows down to the ViewModel and finally back to the UI. This gives us an absolute, non-negotiable rule. The UI never updates itself. It sends events, it renders state. This one-way loop is what keeps your architecture predictable. Section 6. Complete Ownership Map. Who owns what? This table summarizes the ultimate mental model. You don't just need to know the APIs. You need to know who owns what. The process owns the sandbox. The activity owns the screen. The view model owns the screen state. And the repository owns the application data. If you know the owner, you know exactly what survives a rotation. When you visualize the fully assembled, continuously running Android stack, it's a beautiful thing. Events going up, state flowing down, screens dissolving and rebuilding, while the state containers and data gateways hold firm. Your mental model is now complete. If the why finally made sense, subscribe. There are 17 shorts in this series, and each one adds to the picture. Android Atlas. You now know exactly who owns the data and how it survives. But how do you efficiently render that flowing state into a modern interface? Are you ready to build the UI with Jetpack Compose?